as I promised that I will do impulse separate, we did momentum. I hope you watched it. If you haven't watched it, make sure that you watch it so that you can understand momentum and impulse. So today we'll be doing impulse. In momentum, we ended where we're discussing about collisions, the two types of collisions, elastic and inelastic. And we say that you might be asked to prove if a collision is elastic by words or by calculation. So we say that the collision, it is the interaction between objects, right? For an example, I have two players kicking their balls or their soccer balls. I have person 1 and person 2. They all have, each player has its own ball. So when they kick their ball, then their ball collides. So when they collide, they are interacting actually. And as they're interacting, we have something now known as impulse, or as they kick their ball moves from their position to another position. In other words, a force is applied on the ball. So that thing leads us to impulse, which is what we're going to talk about now. So you must know the definition of impulse, which is the product of the net force acting on an object and the time the net force acts on an object. There's a product, there's this weight product. We talked about it, that actually it is the multiplication of the net force acting on an object and the time the net force acts on an object. So in Newton's laws, in grade 11, you were taught that a net force, it is the sum of all forces acting on an object, or the addition of all forces acting on an object. So we get the impulse when we multiply the resultant force, or the net force acting on an object, and the time that the net force acts on an object. As I talked about the two players kicking the soccer balls, and those balls, they interact. So there is a time that those players, when they kick their ball, actually they are applying a force. So that's what we're talking about when we're talking about the net force. So a net force has its own formula of F net multiplied by T equal to change in P. So that's the product of the net force and the time the net force acts on an object. So what you need to understand here is that net force change in T equal to change in P, or impulse equal to change in P. So in other words, or before I explain that, so the SI unit for F net, which is the sum of all forces acting on an object, is Newton, and the SI unit for change in T or time, it is seconds. Then the SI unit for change in P, remember, it is kilogram meters per second. Go and watch that video of momentum. So impulse, when you have impulse, actually when you have change in P, you already have impulse, because impulse is change in momentum, or impulse equal to change in momentum. So if you have impulse, you already have what? If you have a change in momentum, you already have the impulse. Now you need to understand the SI units, or you must know the SI units for impulse. So you have two SI units for impulse. So as this is N and this is S, when you multiply them, you get what? NS. So this is the first SI unit for impulse. Or F net change in T, or impulse, equal to change in momentum. So kg meters per second is also applicable, or it is also an SI unit for impulse. So it is very important for you to know that when you have you can calculate F net or change in T, or rather change in P, in using this formula. So the most crucial thing it is that you can use the formula F net change in T equal to change in P. You can use it to calculate the force, or to calculate the time, or to calculate the velocity. Remember, change in P, it is PF minus PI, which is MVF minus MVI. You can use to calculate the initial velocity, or the mass, or the final velocity. So, but the most important thing for you to know it is that when you have a momentum, you already have what? The impulse. And remember, they like to say in a statement that the momentum on an object changed by, or the momentum on an object changed to. So if they say, for an example, the momentum of an object changes by 10 kilogram meters per second, that means that 10 kg meters per second, it is what? It is the change in P. But if they say the momentum of an object changed to, it means that 10 kg meters per second, it is PF, which is a final momentum, or it is VF, final velocity. So be careful, make sure that you understand what I'm saying. If they say the momentum of an object changed by, that means that momentum, or that 10 kg meters per second, it is the change in momentum because it changed by. But if they say it changed to, which means it is PF, or change or final velocity. So you can go back. Actually, I've explained all of this in that lesson for momentum. So make sure that you go back and watch it before coming here to impulse. Yeah, so you must know the definition, you must know the SI units, because if you can even calculate a impulse and putting wrong SI units, you are actually wrong. Why? Because you must know you must put correct SI units. So I think that's the most important thing. So by what you see on your screen, just go and attempt some questions. So this thing of impulse, it's not a complex thing, but it's a straightforward thing. So all the things that I've explained here are all the things which you must know about impulse. That if you have change in P, you already have what? The impulse. So go and do questions which requires impulse or information about impulse. Momentum leads us to something known as Newton's second law in terms of momentum, which is the net force on an object is equal to the rate of change in momentum. I hope now you understand the term, or these two words, net force. So you can use this definition to define Newton's second law in Newton's laws. So when they say define Newton's second law, you can use this definition, a short one. Net force on an object is equal to the rate of change in momentum. It is also correct when defining Newton's law, Newton's second law of motion. Newton's second law in terms of momentum has the formula F net equal to change in P over change in T, or F net equal to change in momentum over delta T. So that's the formula for Newton's second law in terms of momentum. It's still the same thing, or it's still the same formula as of Newton's second law in Newton's second law of motion. Newton's second law of motion, it's a long definition, so you can use this one if that one a little bit difficult for you. The applications for Newton's second law in terms of momentum. Actually, Newton's second law in terms of momentum, it's actually talks about the safety in our daily living or daily life. Now, the applications for Newton's second law, sometimes, or they usually ask this question, I hope you are familiar with it, when they say, or when they ask you saying, why is it that a person jumping off a tree bends his legs? So what you will say there, as they are asking, why is it a person bending his legs when he jumps off a tree? So what you must say there, it is that that person is bending his legs when he jumps off a tree because he's doing what? He's reducing the time of contact, so that the force to be experienced will be less, resulting in less injury or less damage. I don't know if you understand that. So why a person bending his legs when he is jumping off a tree? So you say that that person is bending his legs when jumping off a tree. So the reason for that, it is that the person is trying to do what? To reduce the time of contact, so that the force experience will be less, resulting in less damage or less injury. This is very important for you to know, why a person jumping off a tree bends his legs. That's very important for you to know. Actually, there are different scenarios, but you answer them, you saying that the person is trying to reduce the time of contact so that the force to be experienced will be less, which will result in less damage or injury. So go to your textbooks and learn about something called crumple zones, seat belts, and what else? Airbags. So those are applications of Newton's second law in terms of momentum. So make sure that you know those questions. They are very important. I think they carry 2 marks if I'm not mistaken. So for you to say to reduce the time of contact so that the force to be experienced will be less, which will result in less damage or injury, you're getting 2 marks. So that's very important. Now we will do some questions. I'll give you questions now. A cricket ball of mass 175 gram is thrown horizontally downwards a player at 12 meters per second. It is hit back in the opposite direction with a velocity of 30 meters per second. The ball is in contact with the bat for a period of 0.05. They say calculate the impulse. So the first thing you must do, you write the formula for impulse, which is F net change in T equal to change in P. Now you say F net change in T equal to the formula for change in P. Then you substitute the velocities and you convert your mass to be in kg by multiplying by 10 to the power negative 3. So then you do what? You use your calculator, you simplify where you have to simplify, then you get your impulse. You get the F net change in T, which is impulse. So number 2, I say calculate the force exerted on the ball by the bat. This is what I was explaining when we were in that part when I was explaining fnet, changing t equal to changing p, that you can use that formula to calculate either fnet or changing t or the changing p. So here they say calculate the force exerted on the ball by the bat. You have your time there, you already have your changing p, which is the impulse, remember. Now the third one, they said calculate the force exerted on the bat by the ball, then motivate your answer by referring to a law of motion. Now look at number 2. They say the force exerted, calculate the force exerted on the ball by the bat. Then number 3, they say calculate the force exerted on the bat by the ball. This is the opposite of that question number 2. So they say motivate your answer by referring to a law of motion. So which is the third law, that when body A exerts a force on body B will also exert an equal force on body A, but in opposite direction. So the answer that you got in the second question, it is the same answer you will get in the third question or the last question, but it will be in opposite direction. So let me say you get 2 as your answer. It means that in number 3, the answer, it will be that's 2 but in opposite direction. So if the answer you got in the second question, it was negative 2 Newton, it means that on that third question it will be positive 2 Newton, because they say in number 2 the force exerted on the ball by the bat. Then on that last question they say the force exerted on the bat by the ball. It is the same answer but now in opposite direction. I don't know if you understand that. So there's no need for you to calculate it, just write the opposite of that answer that you got in number 2. Then you explain in terms of Newton's third law, because it is the law that tells us that for every action there is an equal and opposite reaction. Or when body A exerts a force on body B will also exert a force on body A, but in opposite direction. So please write this activity and leave your answers on the comment platform. So number 1, you write your answer, number 2 your answer, number 3 your answer, then you send them on the comment platform. Then I will also give you the corrections. I know you guys, you will get this. Here's another one. A bullet moves east at a velocity of 480 meters per second. It hits a wooden block that is fixed to the floor. The bullet takes 0.01 seconds to move through the stationary block and emerges from the block at a velocity of 80 meters per second east. See the diagram below. Ignore the effects of air friction. Consider the block bullet system as an isolated system. Then 4.1, explain what is meant by an isolated system as used in physics. In the lesson of momentum, I've explained what an isolated system is. It's a system of zero net force. Then here we are interested in 4.2.2 because that's what that momentum, or where you will be asked to calculate the force or the average force. You must know that part, it is the part of momentum. You can also do 4.2.1. then leave your answer on the comment platform too. That was the last part of what we were doing today. So make sure that you watch the lesson in momentum, or when I was teaching momentum. Alright, thank you guys, and by all the information that you have now, make sure that you understand it and try to attempt questions. Do not forget to subscribe if you haven't subscribed. Like, share to other people. You are helping the channel to grow. So let that be your appreciation. Thank you.